Exponential equations, connecting equations to graphs. What is the template for an exponential equation? An exponential equation can be written in the form y equals a times b to the x, where a represents our initial value, and b represents the growth factor. In this video, we'll be looking at exponential equations and generating a graph, and then we'll go backwards where we start with a graph and write an exponential equation. Problem 1. Here we have the equation y equals 3 times 2 to the x. Before we make a graph, let's go ahead and identify the different parts of the equation. Which part of the equation refers to the growth factor? Looking at our x here, we know that the base of the exponent, this 2, is going to represent our growth factor. Which term refers to the initial value? Notice that this 3 that's being multiplied is going to represent our initial value. Now that we've identified the different parts of the equation, let's go ahead and make a graph. We know that our initial value is 3, so we know that our starting point, or our y-intercept, is going to start at 3. So on the y-axis, we're going to go up 3, and here is going to be our initial value. Since our growth factor is 2, we know that as we move along x, each point is going to be times 2, or twice as tall. So 3 times 2, our next height is going to be at 6. And then 6 times 2, our next height is going to be at 12. Connecting the points, we get this curve. And this is going to be the graph for our exponential equation. Notice that each point is going to be 2 times as tall as what it was before. So that represents our growth factor of times 2. And we have our initial value, or our starting point, of 3. Problem 2. Here we have the equation y equals 10 times a half to the power of x. Before we make our graph, let's go ahead and identify the different parts of the equation. Which part of the equation refers to the growth factor? Looking at our exponent, we know that the base of our exponent is 1/2. So our growth factor is going to be this 1/2. Which part of the equation refers to the initial value? Notice that this 10 that's being multiplied, this constant, that's going to represent our initial value. Now that we identified the different parts of the equation, let's go ahead and make a graph. We know that our initial value is 10, so we know that on the y-axis, on our y-intercept, we're going to start at 10. So here's our y-axis, and here's 10. We know that our growth factor is 1/2, so as we move along x, each point is going to be half as tall as it was before. So moving forward, half of 10 is going to be 5. And the half of 5 is going to be at 2.5. Now that we have our points, we can go ahead and draw a curve through these dots. And this is going to be the graph for our exponential equation. Notice that we have a starting point, or initial value, at 10. And as I move forward, each point is going to be half as tall as it was before. Times a half, times a half. Problem 3. Here we're going backwards. We're starting with an exponential graph, and we're going to try to figure out what the equation is going to look like. Let's start with the initial value. Which of these points refer to the initial value? We know that the initial value starts on the y-axis. So looking at our y-axis here, we see that we cross the y-axis at 0,5. So we have an initial value of 5. We should write 5 in our equation. The 5 is going to be the constant that's going to be multiplied on the outside. So we're going to put the 5 out here. What's the growth factor for this table? As I move forward, how do I go from a height of 5 to a height of 20? That's going to be times 4. Does this pattern work for the next point? How do I go from height 20 to height 80? That's also going to be times 4. And for our last point, from 80 to 320, that's also going to be a change of times 4. So notice that we're repeatedly multiplying by times 4, times 4, times 4. So know that our base is going to be 4 to the x power, because we're repeatedly multiplying with 4. So we have the equation y equals 5 times 4 to the x. Problem 4. Given this graph, let's go ahead and write an exponential equation. Looking at our graph, what's our initial value? We know that the initial value is going to be located on our y-axis. So looking at our y-axis, we see that the graph crosses at 0,4. So we have initial value at 4. Where should we write 4 in our equation? Our initial value is going to go on the outside. It's the constant that's being multiplied. So our 4 goes here. Notice that here we don't have any consecutive points. So we can't figure out what we multiply to go from one step to the next. So let's go ahead and figure out an equation that you can write to help us find the growth factor. How many jumps does it take to go from our 0th term to our 3rd term? Notice that it takes 1, 2, 3 jumps to go from our 0th term to our 3rd term. So we can write the following equation. Starting at 4, if we use 3 growth factors, if we do 3 jumps, 1, 2, 3, we should land at 62.5. So what growth factor can I use so that when I multiply it 3 times, I start at 4 and I land at 62.5. To help simplify this equation, I can divide both sides by 4. And I see that I need 3 growth factors, multiply 3 times, in order to get 15.625. So what 3 numbers, if I multiply it 3 times, is going to be 15.625? I see that my growth factor is going to be 2.5. If I multiply by 2.5 3 times, I'm going to get 15.625. So know that each of these points are going to get 2.5 times bigger, times 2.5 times 2.5. Since I'm repeatedly multiplying with 2.5, I know that my growth factor underneath the exponent is going to be 2.5. So the equation y equals 4 times 2.5 to the x. To summarize, connecting equations to tables, we know that an exponential equation can be written in the form y equals a times b to the x, where a is our initial value, which can be located on the y-axis, or the y-intercept of our graph. And we know that our growth factor b is going to be our multiplicative pattern, is what we multiply to go from one point to the next.